Hello everyone, thanks for joining us at 2021 Esri Virtual Developer Summit. My name is Jay Zhang, and I'm a product engineer from Esri's Imagery development team. In today's workshop, I'm going to talk about the automation of managing and sharing raster data for analysis in ArcGIS. The focus of this workshop is on the sharing part. I'll show you a couple of different scenarios how you can access your raster data, automate the workflow to publish your raster data as image services onto the image server through ArcGIS Enterprise. So here's a quick agenda of what this workshop covers. I'll give you a quick review of what type of raster data is supported by ArcGIS, and the data models that we use to represent raster data, and the APIs you can use to automate the management and sharing workflow. And then I'll present to you a couple of different scenarios you may run into, such as sharing a single raster data as a single image service layers, or how you can use additional data model to manage a collection of raster data and sharing the collection as an image service, and how you can convert and share cloud raster format data that is in nowadays contemporary cloud storage such as Esri, Azure Blob Storage, or Alibaba Cloud Blob Storage. And then I'll also show you some tricks how you can keep your raster data shared as image service up to date, how you can update your collection of imagery without interrupting the service. And finally, I'll briefly mention that the additional capability that is provided by ArcGIS Enterprise Raster Analytic platforms to perform distributed analysis on the image service data that you shared to ArcGIS Enterprise in scale. So let's do a quick review of what type of raster and imagery data support we have in ArcGIS. The ArcGIS Imagery platform is a powerful system of record that is capable to read and display and perform analysis on different types of imagery data, including aerial sensors, drone, and satellite sensors. You can visualize LiDAR data, panchromatic data, multi-spectrum data, and perform analysis on scientific data, multidimensional scientific data, radar data, and of course the RGB image. And when raster data is being presented in ArcGIS, we use this two common information model. When we're referring to raster dataset, it usually represents a single dataset that is a raster dataset or a combined dataset from a satellite scene. You can also use the information model we said as the Mosaic dataset to manage a collection of imagery data. Mosaic dataset is a very powerful data model that supports dynamic mosaicing of a collection of imagery, and it also provides a table view that shows all the imagery items in the collection as a table of records. And it also can give you, the Mosaic dataset itself can also be considered as a single raster dataset. And it must be living in a geodatabase, either in the file geodatabase or in the enterprise geodatabase. And raster dataset can also be multidimensional. We can represent spatial data, temporal data, and vertical dimension data altogether within one single raster dataset. One single dataset can contain one or multiple variables in one file. A variable is like a cube or cubes that across a time dimension or other vertical dimensions. And each slice of one variable is a 2D array. And multidimensional rasters can actually be coming from a Mosaic dataset or a raster dataset or a single raster dataset, which means if you have a collection of time series data, you manage to use a Mosaic dataset, and the Mosaic dataset can also be considered as a multidimensional raster. Now it's important to know that there are two sets of Python APIs provided by ArcGIS that supports management and sharing workflows. There's one ArcGIS API for Python, which is the ArcGIS Python module, where you can install it to work with ArcGIS Enterprise and ArcGIS Online. It can be seen as a client library that supports service requests to the ArcGIS Enterprises, image services, or analysis services to perform remote processing. On the other hand, you may also be familiar with the ArcPy Python module that is provided through our desktop apps such as ArcGIS Pro, ArcMap, or ArcGIS Server. And the ArcPy module is also available in hosted notebook servers advanced runtime. By using the ArcPy modules, you can perform local processings, running geoprocessing tools, or utilizing the ArcPy API to perform to create raster object and perform analytic workflows using raster functions or geoprocessing tools. Now, what we are going to start talking about is a simple data sharing scenario to publish one single raster dataset as an image service, and how you can use Python to achieve that. So, publishing a single raster dataset as image service is straightforward. We support any format. We support any raster format that is supported through ArcGIS Imagery platforms. If your image format can be read by ArcGIS Pro, it can be published as image service. And also, you need to be noted that some format may require additional license in order to publish to the image server. And sharing one single raster dataset actually does not require the image server extension license. And we provide the sharing user experience from ArcGIS Pro, where you can publish a single image through the image service publishing wizard, or you can publish the single raster dataset from ArcGIS portals, create imagery layer user experience, or you can directly calling the ArcGIS admin REST API to create an image service pointing to a raster dataset. And there are two ways you can move the dataset to the server. One way is you can upload raster to the hosted data store that is configured on your ArcGIS image server. It's the by value mode. Or you can grant it permissions of the folder or the workspace that contains your raster data to the enterprise account. And then in that case, the image service can just directly access the data without moving it around. So that is the by reference publishing mode. Now let's move on to a quick demo. And in this demo, I'm going to show you what's the straightforward way to publish a single raster dataset as image service using Python. In this particular example, I've created a notebook in ArcGIS Pro, and I'm going to use several Python APIs to make ArcGIS Server's admin to utilize the ArcGIS Image Service REST admin API to create an image service pointing to a single image. The first step is to import required Python modules. For the fellow Python developers, we know that request library can make REST requests to the remote server. So I'll import some necessary Python modules, JSON request, and then I'll make a connection to my ArcGIS Enterprise and the federated image server using my username and passwords. and then generate the token with my username and password to be used for the create service admin API. So as you can see here, I'm making a REST request invoking the server admin's generate token API using my username and password, and define expiration time, and then use the server URL as referral. And once the token has been generated, I can use it in the next step to create a service. Now, an image service can be represented in the form of JSON. In these particular examples, you can see that I define my image service using this JSON dictionaries. And I have to give a service name, define the type as image server, and then define the basic capabilities that I want this image service to have. And then the other important property of the service definition is the path property, where you need to define the actual path to the imagery file that you want to publish as image service. Once you finish defining your image service configuration, the next step is to decide how you want to publish this service. I want to, in this examples, I want to publish the image service by reference, which means I need to grant the permissions to my image server account to the location where I store my image. In this case, it is this folder on the Valeria machine, and then the folder name is Z-Submit 2021. So I can grant the permissions to my ArcGIS server by creating a data store. And you can also use the ArcGIS server's admin API to register a data store item. And the data store item can also be represented in this JSON syntax. In this particular example, I want to create a file share data store pointing to this particular folder. And I'm making a request, register item request, to register this data store location to the server. And also I was using token that I created in the last step. And once you make the request, it will tell you whether it succeeded or not. In this case, I have already created this data store earlier, so it will just tell me it's already existed. Then once you have the data store registered and the image service definition defined, then you can use the ArcGIS admin API's create service call to create a service. Now in this REST request, you need to provide a token, the service definition, and also the referral. And then by submitting this request, a new image service will be created on your ArcGIS server. And the status shows as succeeded. And then I can reconnect to my ArcGIS Enterprise and actually display the single image service here in the notebook. The image I published here is a digital elevation model image, digital elevation raster dataset as a single image service. So this concludes my first demo. Now coming back, the second data management and sharing scenario I'd like to mention is utilizing Mosaic dataset. In this scenarios, I'll show you a few examples of how you can use Python to automate the Mosaic dataset imagery management and sharing workflows. And for those of you who are new to Mosaic dataset, when you're using Mosaic dataset to manage your raster data and to adding those information about the raster dataset into the Mosaic dataset table, you need to use the appropriate what we call the raster type. Raster type basically defines and tells ArcGIS product what kind of imagery data you want to ingest into the Mosaic dataset table. It is a predefined set of metadata for a particular type of raster data. For example, if I want to use Mosaic dataset to manage Sentinel-2 satellite data, then I should be choosing the Sentinel-2 raster type. And raster type also defines based on the type of data, I also define certain preset processing template. For example, if you have a pen-sharpened satellite scene which contains multiple imagery files, the specific raster type may be able to define a processing template that combines the pen band and the multispectrum band together to generate a pen-sharpened raster items in the Mosaic dataset. And as of today, in ArcGIS, we support over 70 different type of raster types. And these options are available through Add Raster to Mosaic Dataset or Add Raster to Mosaic Dataset GP Tools raster type drop-down list. Mosaic Dataset can manage data from satellite, from UAV drone, from aerial and scan, from aerial photos and scan image, and it can also manage data which is multidimensional in the scientific data format such as NetCDF, GRIP, or HDF. It can also support radar data, LiDAR data, and even GIS services such as WCS and WMS. And you should be choosing the appropriate raster types when you are ingesting the data into the Mosaic Dataset table using the Add Raster to Mosaic Dataset tool. If the incorrect raster type was picked, and the data will not be able to correctly add it into the Mosaic dataset. And if you happen to have a type of sensor that is not supported by the existing raster type in ArcGIS today, the raster type is actually also extendable with Python. You can use Python and to write your own interpolation methods for the sensor that wasn't supported by ArcGIS yet to create this custom raster type. And once you have added the raster dataset into the Mosaic dataset, one thing to be noted as the raster data itself is actually not being copied into the Mosaic dataset table. It is only being referenced by the Mosaic dataset. Only the path or the workspace information about the raster is being stored in the Mosaic dataset table. And today we have over 32 different geoprocessing tools to work with Mosaic dataset data management workflows. You can find them under the Data Management System toolbox, Raster, and then Mosaic dataset toolset. The Mosaic dataset tool supports the creation workflow. You can create the Mosaic dataset, add rasters to Mosaic dataset. You can also modify Mosaic dataset, such as building footprints or define node datas. And it also supports imagery enhancement workflows, such as building simline or color balance Mosaic dataset. And because the Mosaic dataset is also a table of record, you can utilize some ArcGIS ArcPy API that works with table to manipulate the record in the Mosaic dataset table, such as the data access update cursor allows you to update the field values or add new field, update new field value, delete field values in the Mosaic dataset table. And to share the Mosaic datasets in the service, your ArcGIS server does require an image server extension. And again, the sharing workflow can also be performed through the image service publishing wizard. You can also create the Mosaic dataset through the ArcGIS portal's create imagery layer user experience. And the ArcGIS server admin API is also good for you to create image service that is pointing to the Mosaic dataset. The image service, when you are sharing the Mosaic dataset as image service, one thing to be noticed is that the image server will need access to both the Mosaic dataset itself, to the geodatabase location where the Mosaic dataset is stored, and also the raster data that the Mosaic dataset is referencing to. Since the raster dataset, they are not being copied into the Mosaic dataset table inside the geodatabase. Now, in the second demo, I'll show you how you can write a Python script to automate the Mosaic dataset data management workflow and share Mosaic dataset as image service. Again, I create this notebook in ArcGIS Pro to show the examples of creating Mosaic dataset to manage raster data. The first step is to import the required Python modules. In this case, I'll need to use the ArcPy Python module to perform the Mosaic dataset creation and management workflows. The first step is to create a geodatabase that houses the Mosaic dataset I'm going to create. And you can either create a Mosaic dataset in a file geodatabase or enterprise geodatabase. In this particular example, I'm creating a file geodatabase under this folder. And then I can use the create Mosaic dataset tool to create a Mosaic dataset to manage my NDFD weather forecast data, 4-day weather forecast data. And I'll always need to define a spatial reference for the Mosaic dataset. So in this case, I'm going to create my Mosaic dataset in this file geodatabase, give a name, and also the spatial reference, which is GCS WSGS 1984. And once the Mosaic dataset is created, it's still empty. It actually contains an empty table. And then the next step is to actually add the raster data reference to the Mosaic dataset. The weather data I want to add it into the Mosaic dataset is this NDFT temperature forecast data for the next 4 days in 2020. And then this is in the format of grid. And in this particular example, remember that you need to choose the appropriate raster type for the data you want to add it into the Mosaic dataset. In this case, I'm adding grid data, so I need to specify a raster type as grid. And there are additional options you can specify in the Add Rasters to Mosaic dataset tool to filter out the variables you want to add it into the Mosaic dataset. In this NDFD data, I want to add a temperature variable only to the Mosaic dataset. So I'll define an additional auxiliary input filter to specify the variable I want to add from this bin file, from this grid file, to the Mosaic dataset is t add htgl. And then I can execute this add raster to Mosaic dataset tool. It will crawl through all these different variables in the bin file and add this multidimensional temperature data into my Mosaic dataset. And once my Mosaic dataset is created, as you know that I can do some additional processings on the data in the Mosaic dataset, such as calculating statistics for each slice of the temperature data throughout the time series. And because the NDFD data actually stores temperature in the unit of Kelvin, and I want to do a conversion at the new field to the Mosaic dataset table to convert the temperature value from Kelvin to Fahrenheit. And I can use the add field tool, which works with table type of dataset on the Mosaic dataset as well, to create this new field. And I can specify the field type is double. And then I'm using the search cursor to read the raster items by specifying the raster field from the Mosaic dataset. And I'm again using the update cursor to loop through each row of the Mosaic dataset and reading the temperature information, the mean temperature information from the raster item, and then do the conversion to convert from Kelvin to Fahrenheit, and then save it back to every row's regional average Fahrenheit field. And one thing you need to be noted here is why I need to use two types of cursors. And because the search cursor is defining a read-only cursor to read this object ID field and raster field from the Mosaic dataset table, because we actually cannot update the raster field. while the update cursor is actually used to update the new field that I added into the table, which is this double type regional average Fahrenheit field. So this example basically shows that how I can read raster items from the Mosaic dataset and also updating the field values inside the Mosaic dataset for each rows. And once I finish updating my Mosaic dataset, the next step is to share the Mosaic dataset as image service. Now the step is the same as sharing one single raster, and you need to generate a token. You need to connect to the server that you want to publish your data to and generate a token using a username and password, and then define the image service definition. In this particular case, I want to highlight that because the dataset I want to publish is a Mosaic dataset, therefore I want to grant some additional capabilities to the image service, such as the catalog capability. The catalog capability basically allows the client who consumes this image service be able to access the Mosaic dataset table. And once I've finished defining my image service, I can invoke the create service API to publish the image service again. It's coming to the map, and this is the Mosaic dataset that I have created through this workflow. And if you go into this footprint table, you can see that it only contains the variable, which is the temperature variable from the grip dataset. And the product name is grip1. And it also contains the newly added field that is to store the temperature in the Fahrenheit unit. And the conversion formula works correctly to record the average regional average temperature for every raster slices in this Mosaic dataset. And after I have published it as an image service, you can also view it on map, and because I enable the catalog capability on the image service, you also have access to the Mosaic dataset table. That is through the image service, and it contains the same information. The new field that stores the regional average temperature in the Fahrenheit unit. All right, this concludes my second demo on a Python automated workflow to manage data with Mosaic datasets and publish Mosaic dataset as image service. The third data sharing scenario I'd like to talk about is the cloud raster data management workflow. ArcGIS support read and write raster data in the cloud store. The cloud store here referring to the cloud object storage. As of today, ArcGIS support the Amazon AWS S3 blob storage, the Azure blob storage, and Alibaba storage, blob storage. And in ArcGIS Pro, you can create a ACS file, which is referring to the ArcGIS Cloud Store connection file with the Cloud Store account name, so access key or secret key, to establish connection to the Cloud Store. And on ArcGIS Enterprise, on ArcGIS Server, the way to establish connection is through creation of a data store item of the type of Cloud Store. In the similar to the previous example, you need to use the Cloud Store's account name, access key, or secret key, and define in a JSON object to register data store items. And once you have established the Cloud Store connections, ArcGIS support reading of any raster format that is supported by ArcGIS from the Cloud Store. And you can also use ArcGIS provided tools to transfer files to the Cloud Store. You can use the transfer files GP tool to directly move the imagery file and its auxiliary files through the Cloud Storage connection to the blob storage. You can also use the copy raster tool to convert the raster dataset from its original format to the new cloud raster format and storing inside the Mosaic, storing inside the cloud blob storage. Or if you don't want to use the Esri provided tools, you can also use third-party tools such as Azure Blob Storage Explorer or Esri Browser or Cloudberry to transfer your data. And if you have cloud rasters and Mosaic dataset can actually support referencing the data in the cloud store. And for the best practice, if you want to perform analysis on the raster data in the cloud storage, the tip is to deploy your analysis servers close to the cloud store regions. For example, if you want to run analytic tools in the AWS cloud, then it's better to set up the virtual machines in the same region as your S3 bucket. And you can also you will also want to use some cloud optimized raster dataset format, such as the cloud optimized GeoTIFF, or use the cloud raster format that is coming from Esri. Now I want to talk a little bit more about the cloud raster format and why you want to use it. Cloud raster format is a Esri proprietary format, aka CRF. Right? It is a enhanced version of a tiled raster dataset and with a predefined optimized tiling schemes. And because this tile structure and the raster dataset in this format is actually optimized for distributed analysis and rendering, it can support fast parallel read and write, and it can also support local cachings when ArcGIS Pro or ArcGIS servers is using those datasets for rendering and analysis. And our web clients, such as the ArcGIS Online Web Map and also the JS API, is also enhanced to support accelerated client processing and renderings if the image service is referencing to the cloud store, to the cloud raster format raster dataset. And it's especially good, this format is especially good for multidimensional rasters. And if you store multidimensional rasters as in this cloud raster format, and the client knows how to utilize the data structure to perform fast slicing operations. And you can even store the transposed dataset in the same CRF for optimized profiling operations. Now, in the third demo I'd like to show you, I'll show you the Python script to automate your workflow of managing a collection of imagery data in the S3 bucket using Mosaic dataset and sharing the Mosaic dataset as image service. In this example, I'll be importing all the Python module that I need to use. And the next step is to establish the AWS Cloud Store connections. And we need to provide the Cloud Store name, the provider name, which is Amazon in this case, and providing the access key and secret key to authenticate the connection, and then specify the bucket you want to connect to. And then have a location where you want to store your ACS connection files. And then you can invoke the create cloud storage connection file GP tool with all those information to create this ACS connection. Once the ACS connection is being established, you can see that you can actually browse into the connection and see what kind of data is in this bucket. In this case, I have a connection created earlier, and in this connection, I have a folder containing some Landsat 7 imageries that is taken around the Yosemite region. And then the next step is to create a Mosaic dataset to manage this data. Similar to the last example, I want to create a Mosaic dataset in this geodatabase and give a name and the projection. After the creation, I want to use the Add Raster to Mosaic dataset tool to ingest my data into the Mosaic dataset. And because I know that the imagery data stored in this blob storage is the Landsat 7 ETM raster type, So I'll be using the Landsat 7 ETN plus raster type keyword. And the actual path I'm going to use to reference to this data is this ACS connection file path. And I want to use the processing template of multispectrum, which automatically combined this individual band TIFF files from a single Landsat scene to a multi-band raster. And executing this tool, this will ingest all the 6 raster items into the Mosaic dataset. And then the next step is I want to publish this Mosaic dataset to the server. Remember that when you are sharing Mosaic datasets image service, the image server will need to have access to both the location of the Mosaic dataset and also the data it reference to. So what I need to do here is, first of all, generate a token to invoke the image server's REST API. And then I want to register a data store item that is referring to the Esri bucket that I was using to store my Landsat 7 data. And you can define a data store item which is of type cloud store to establish connection to the Amazon S3 bucket. And here in this JSON syntax, you need to define this connection string that contains the information of access key and secret keys, and also specify the provider name and object storage, which is the name of the container or the name of the bucket. And then you can call the same API, the register item API, to register this data store item to the server. Once the data store item has been created, and then again, it's the same as last example, you want to define the image service definition pointing to the new Mosaic dataset I just created here, referencing Landsat 7 Yosemite data, and then call the create service to create a dataset. And once the Mosaic dataset has been created, let's take a look at it. This Mosaic dataset that contains 7 Landsat scenes is actually referring to the data stored in the S3 bucket. And when I publish as image service, again, it's the same data, and the server is also able to directly access those Landsat TIFF files in my S3 bucket. And of course, if you don't want to use your Mosaic dataset to manage your data, you also have the option to, if you don't have the need to use a Mosaic dataset to manage your data, you also have the option to directly convert your entire collection to a CIF format raster dataset and share that CIF dataset as a image service to optimize the performance when you're accessing these services or use these services as the analysis workflow input. And you can directly use the copy raster to convert the Mosaic dataset I created earlier to this Yosemite Landsat 7 CIF raster dataset. You can actually do that directly using the ACS connection file path. Now this concludes my third demo on managing cloud store rasters using Python. Now I've seen 3 data management sharing scenarios. The fourth example I'd like to show you is how you can update the data shared as image service without stopping the image service. What I was referring to by live update is there's been a lot of user workflow out there that once the raster dataset has been shared as image service, there may be a need to update the raster dataset without stopping the service. For example, the user may want to update the existing rasters with a newer version, or there are new raster data coming in to the image collection that the user wants to append into the collection without stopping the service. In order to support that kind of operation, there are some requirements need to be met. If you are sharing Mosaic dataset as an image service, the Mosaic dataset will need to be created in the Enterprise geodatabase. The file geodatabase Mosaic dataset is not supported for live updates. And once the Mosaic dataset has been shared as image service, you also cannot update the schema. What it means is you cannot adding a new field to the Mosaic dataset while the image service is up and running, and also delete existing field, or delete and add additional side tables to the Mosaic dataset. But removing and adding record in the table without stopping the service is supported. In the upcoming image server release, we'll also support live update on the cloud raster format raster dataset. Now let me show you a quick demo on how you can enable live update operations on a Mosaic dataset type of image service. In this particular examples, I've already shared and published a enterprise database Mosaic dataset as image service. As you can see here, before I publish my service, similarly I need to generate the service admin token and then register the enterprise database connection information as a database raster store to the server. This is what the enterprise database data store JSON looks like. In this case, my Mosaic dataset is created in a Postgres geodatabase, and I have to register a Postgres database data store item to the image server that I will be sharing my image service on. Once the data store registration is completed, you can define the image service. And the image service also contains the connection information. And then you can create a service to publish it. Once the image service has been successfully published, and without actually stopping it, you can run additional Mosaic dataset management tools, such as removing existing raster records from the Mosaic dataset without actually stopping the service. So in this particular example, I have published, the Mosaic dataset I have published is the NDFD Mosaic dataset that contains 4 days of temperature forecast data. And in this example, I'll be removing some old records, that is the temperature data before March 21st of 2020. And without stopping the service, I can actually remove the records from the Mosaic dataset. And then the reason I want to remove those old records is because I have my new data coming in. And I can just simply call the same add raster to Mosaic dataset tool and pointing to the new version of the temperature data that is covering the time period from the March 15th, 2020 and forward to this Mosaic dataset. And also, as you can see here, I'm not stopping the image service. Just using the new data file pass and specify raster type and define a variable name, and then invoke the add raster to Mosaic dataset tool to add the new data to the Mosaic dataset. And without stopping the service, my service will be automatically updated next time when the client added the image service to the map and open the table, you will see that it contains the new version of the data that is actually coming from this new grip files. Now this concludes my first demo. The last thing I want to mention in my workshop is how you can perform distributed raster analysis with image server on those image services that I shared earlier in my previous demos. So ArcGIS Enterprise with image server actually provides this ability to perform distributed raster analytic workflows. And there are many raster functions and the tools you can utilize in ArcGIS Enterprise to perform workflows such as data management workflow, arithmetic workflow to manipulate the pixel values by using a custom formula, hydrology workflows, distance and density workflows, and you can also compute vegetation index analysis workflows. And you can actually set up and configure a ArcGIS Enterprise with the raster analytic capability to support the distributed raster analysis workflows. And this is the typical configuration. This is what the typical configuration looks like. So with the ArcGIS Enterprise, you may have different server sites serving different roles. Through the ArcGIS Enterprise wizard, you can configure a particular federated image server to be used as the raster analysis servers. And you can also configure additional image server that is used to serve the hosted image services. And with this kind of configurations, you can designate the raster analysis image server to perform distributed raster analysis utilizing multiple server nodes by using the input image service from the image hosting server or the feature data from the hosting server. Now, if you want to learn more about distributed raster analysis workflows, I recommend you to check out our documentations, particularly focused on this part. But we will not be digging into too much of distributed raster analytic workflows. Now, in this workshop, I've shown you 4 different demos. Basically, give you an overall introduction of how you can manage and share your raster data as image services, either using a single raster, using Mosaic dataset to manage image collection, or managing a cloud raster in the cloud blob storage. And the last but not least, I mentioned the ability to live update in service from Mosaic dataset case. So all this demo code I show you today is downloadable from my GitHub page. Please check this out and give us any feedbacks you may have. And thank you very much for your interest in this workshop today. I wish you enjoying the rest of the 2021 Esri Virtual Developer Summit. Thank you very much.